This is Unity. It's a game engine, which means it just has some things built in which saves me a lot of time. This section is a list of everything in the current scene, so there are the walls and the floor making up the environment, but those are only visual for now so that I can see how the player is moving. This player object is currently acting a bit like a folder, and you can imagine the capsule object is a folder within it. The capsule is just the shape that's currently representing the player's character, and it also has some things assigned to it. A rigid body 2D, which allows this capsule to move around and collide with things, and a script called Player Controller. So far, this script has some information about health, movement speeds, and movement-related keyboard input. This input data is stored in a vector called movement input, which has one value for movement along the x-axis, and another value for movement along the y-axis, where -1 is left or down, 1 is right or up, and 0 is no movement. There's also a rigid body variable, which will be used to refer to that rigid body we just saw on the capsule. This section here runs when Unity automatically calls this start function at the very start of the game. The first line in this function is an if statement, so the code between these curly brackets will only run if the provided condition is true. So in this case, if for any reason the program cannot find that rigid body component we just saw in Unity, the program will send me an error message. The next line sets the player character's health to the maximum value, which I've already set in Unity here. I could just set current health to 100 in Unity as well, but this way, if I decide to change the maximum health value, I don't need to also change current health. This isn't the best example, but it could be really helpful with more complicated objects. Now on to the update function. Also called automatically by Unity, but unlike start, update runs every single frame. It calls a different function, getInput, so we can jump to that. It checks if any movement buttons were pressed and stores this information in the movement input vector, with left-right movement in the x value and up-down in the y value. The next line makes sure the vector has a total distance of 1 so that it can be accurately scaled by speed values. This is just because diagonal movements would end up being greater than 1 unit per frame and faster than intended. The next line checks if the sprint button is being pressed, and the last line of this function multiplies the movement vector by the speed values. It contains an if statement in shorthand, so the movement input, which now has a distance of 1, is multiplied by the walking speed. Then, if the sprint button is currently held down, it is also multiplied by the sprint multiplier. However, all this code doesn't actually move the character. This is where fixed update comes in. Again, automatically called by Unity, but 50 times per second by default, no matter the frame rate. It's usually used for physics, so it needs to be calculated at consistent intervals. Here, I calculate the new position for the character by adding the movement vector we just calculated to the player's current position vector. That time.delta time bit just ensures movement speed is scaled correctly, or in this case divided by 50 due to this movement happening 50 times per second. And that's it. I can move the player around and hold shift to speed up.